Welcome to Edexcel demola, and today's lesson we're going to be covering ionic equations. So in the last chemistry lesson we did about formulating and balancing your equations, but what I kind of left out was the ionic because I thought it was a bit complex. So I want to dedicate this whole lesson into making sure that we get that right because they can be a bit difficult to understand, but they are quite good marks to pick up in exam. Okay, so before we even get into ionic equations, I want to cover this concept of dissociation. So what does that mean? I've got it here when electrons dissolve, when electrolytes dissolve in an aqueous solution. But you can also think of dissociation as like the splitting of a molecule or splitting of a salt or something. So in this example, salts splitting off into ions. Right? Some substances will fully dissociate, others only partially dissociate. We can talk more about that in later topics. Not too relevant now, more relevant for organic chemistry, right? So we're going to focus on physical. Now, I just wanted to show you this as an example of what's actually happening, although we don't normally show it like this. So you've got hydrochloric acid plus water going to your hydronium ion HVO plus Cl minus, right? That's what's actually going on. However, we don't really show it as that just because it's a bit too complicated, right? So what you'll normally show that is hydrochloric acid dissociating into H plus and chloride ions. Yeah? Happy days. Now, just be aware of this as well. Acids are going to release protons, H plus ions, right? So, for example, hydrochloric acid only has one, so it'll release one. Yeah. Sulfuric acid has two hydrogens, so it's going to release two protons. Your phosphoric acid has three hydrogens, so it releases three protons. You get what I mean? So these are all strong acids that are fully dissociating. And similar thing when you have a strong base. Your bases are going to release hydroxide, OH minus ions. So sodium hydroxide, only going to have one hydroxide ion released. Yeah. Calcium hydroxide, you can see two hydroxide ions are being released. So that's with acids and bases. And just salts will release that ion. So like we had it at the top. Oh, we didn't have it at the top, sorry. I don't know where I've got that from. But for example, sodium chloride, if we just draw it out. Sodium chloride, I'll just put it here. It's gonna go like Na plus, I don't know this, NaCl aqueous goes to Na plus aqueous plus Cl minus also aqueous. Yeah? So that's going to split into its ions. And your insoluble salts do not release the ions. Module 3 is going to be more important while we will talk about which salts are going to be insoluble. The main one that you should remember is barium sulfates. Cool. Okay, now we've done a bit of the pre-work. We're going to get into ionic equations, right? So, first of all, we need to define what a molecular equation is. Molecular equation, we're going to have the formula of each compound written as though all substances exist as molecules. We did this in the last chemistry lesson when we had just the equations. You're showing all the elements or the number of atoms of each element in the compound. Yeah. What's your ionic equation? We only really want to show the ions that are involved. And that's going to link to your concept of spectator ions, which are going to be the ions that are not involved in the reaction. They remain unchanged. You are going to see spectator ions. We'll get into it. Now, types of reactions using ionic equations. Right? These are your big three. Cool. You've got neutralization, you've got precipitation, and you've got displacement. So in a neutralization reaction, you have an acid plus a base making salt plus water. And I've shown what an ionic equation will look like with that underneath. It will just be proton plus hydroxide ion goes to water. Yeah. Your precipitation reactions is when you form a solid precipitate. So you've got two aqueous ions joining to form a solid precipitate. Yeah, a solid salt. Displacement reaction, one element is replaced by another. We're going to get more into that as well. But you can see here, the A is replacing X. So the A is by itself, it's replaced X, which was in an ionic form, meaning it must have been in a compound, right? And you can see on the right-hand side the products that's swapped over. Now, I've just done this example of a ionic equation, right? So you have the full equation, sodium hydroxide plus hydrochloric acid goes to sodium chloride plus water. Now, if we draw our ionic equation, and forgive me, I shouldn't have had these already done, but it is what it is. We had sodium ion plus hydroxide ion plus the proton plus the chloride ion. Do you see how we got that from these compounds? So like your sodium hydroxide made up of sodium and hydroxide, and hydrochloric acid made of hydrogen, ion, and chloride. Yeah, cool. And on the other side as well, because it's still aqueous, this is really important, because it's still aqueous, we're looking at what's aqueous, right? You've got your sodium ion plus your chloride ion going to make water. Water you're just going to keep it because it's a liquid. Yeah. Then your spectator ions are the ones that are on both sides. So if they're on both sides and they're completely unchanged, it means it's a spectator ion. We can cancel it out, which is why I've drawn a line through it. Yeah? So when you do that, all you have left is H plus aqueous plus OH minus aqueous goes to water. And if you remembered properly, this reaction type is called neutralization. And again, we're going to be looking at the ions that remained unchanged, which was your sodium and your chloride. Cool. So I've just got another example for us to look at, right? Another reaction. You've got barium chloride plus sodium sulfate goes to barium sulfate plus sodium chloride. Yeah? Cool. I've drawn out the molecular equation as well. You've got BaCl2 aqueous plus Na2SO4 aqueous going to BaSO4 solid plus 2 NaCl aqueous. Just remember, barium sulfate always going to be solid. Cool. We split the ions, right? Let's look at what's aqueous here. So if we do it in maybe purple. I'm looking for aqueous because these are the ions that are going to split. That's aqueous. That's aqueous. This is aqueous. So we know which ions are going to split, right? So you got the Ba2 plus. You got the Cl minus, but there's two of them. You can see here, there's two of them. So we need to be aware of that. So we're going to put the 2 in front of it. Cool. Next, we move across. This is okay. So aqueous. So you got Na plus, but there's two of them again. Yeah. So 2 Na plus, aqueous, and then you got the SO42 minus, also aqueous. Cool. Barium sulfate, solid, we're going to leave it. So it's going to say it's barium sulfate. And you can see here, because of this 2, we're going to have 2 Na plus and we're going to have 2 Cl minus. Cool. Next step, we need to cancel out the spectator ions, right? So what's unchanged? I've got 2 Cl minus on both sides. They got to go. I've got 2 Na plus on this side. They got to go as well. Cool. And that means that all you're left with is Ba2 plus aqueous plus SO42 minus aqueous goes to BaSO4. And that's how you work out your ionic equation, right? The spectator ions, we identified them, right? Those Na plus and Cl minus. And the type of reaction here, well, you're forming a solid salt, right? You're forming a solid precipitate. This is a precipitation reaction. I hope that made sense. Now, reactivity series. Guys, really, really important that you know your reactivity series, right? And there's this funny, I guess, it's not really funny, but you got an acronym here. Please stop calling my annoying colorful zebra. Instead, try learning how copper saves gold and platinum. That's how I used to remember it. And literally what that is the starting letter of each one represents an element, right? So potassium is right at the top of your reactivity series. So this is going to be the most reactive. So, this is your most reactive one, yeah? Potassium. Whereas the least reactive is going to be your platinum. So platinum is very unreactive, yeah? Just key points as well, because these aren't metals. Hydrogen and carbon, they're just important to know which elements are more reactive than carbon, which ones are less reactive than hydrogen, you know what I mean? So be aware of the reactivity series. Try to be confident with it. I think if you can learn like a mnemonic or an acronym, it will really help you out with this. Okay, so it's question time. We've only got 3 today. 2 of them are pretty short, so just have a go. Pause the video, give you time, and then we'll come to the answers. And these are your answers. So if we focus on question 1, right? Which of the following metals will displace ions from iron to sulfate solution? Yeah. Sorry, I said that really badly. But what you kind of need to do, you have to think back to the reactivity series. And the only one that's more reactive than iron here is going to be zinc, right? So that's question 1. Now question 2. Zinc reacts with copper sulfate solution. Write the full ionic and net ionic equations. Although I don't think that was the same question, but it would have been to write your ionic equation with state symbols. Right? So again, zinc, metal, it's going to be solid. Cool. The copper sulfate solution is going to be aqueous. Those are the first things you need to remember. Then, we look back to the reactivity series, yeah? Zinc's above copper. So that means that zinc displaces copper from the copper sulfate. So you form zinc sulfate and copper. Cool. You got that as the baseline. Now, we needed to split into the ions. Zinc's fine as a solid, yeah? So we leave it. Copper sulfate's aqueous, so we need to split it into its ions, Cu2 plus and SO42 minus. Cool. Now go to the other side. Zinc sulfate's aqueous. So you got the zinc 2 plus and the SO42 minus. And then you've got the copper by itself because it's solid. Now, again, what's the same on both sides? I see the sulfate on both sides. So I want to get rid of that. Yeah? But that's literally the only one that I see on both sides.
So then we can write that as an ionic equation. Zinc solid plus Cu2 plus aqueous goes to zinc 2 plus aqueous plus Cu solid. And that would be a displacement reaction. Cool. Last one, why does copper not react with hydrochloric acid? Again, we've been kind of building on this theme, right? Copper was below hydrogen, right? So that means that copper cannot displace hydrogen ions from hydrochloric acid. And that is why that would be our answer. Okay, and it's finally time to get into your A-star tips. Remember your reactivity series. Really, really important that you know the whole reactivity series so that you can tell if this ion is going to displace this ion. Yeah, if this metal displaces this metal. What else? Different types of reaction, yeah? Neutralization, displacement, precipitation. Just know them, yeah? Full workings out. Guys, it will limit so much mistakes if you just do the full workings out. It's a bit long, it's annoying, but you don't want to make a mistake in the exam. So I would go through the whole process. Identify and remove the spectator ions as a part of that process. And guys, I cannot stress it enough. State symbols is so, so important. You can, it's an easy mark to get by just including state symbols, so just do it, yeah? Okay. Don't answer the molecular equation, yeah? This is what you don't do. Don't answer the molecular equation. Make sure you read the question really carefully so that you can tell they're asking for the ionic equation here. You can get that question right, yeah? Again, I'm going to just emphasize again, I wouldn't skip steps. I would just do the whole thing out because really, worst case scenario, you pick up some workings out marks. And you should, chemistry, people normally have enough time. So I wouldn't worry too much about timing, yeah? Don't split precipitates into its ion. In fact, just anything that isn't an aqueous compound, as a rule of thumb, don't split it off into its ions, yeah? It will only be the aqueous ones that you really want to split off. Okay, I hope that was a really helpful video for everybody. Please subscribe, drop a like. Any questions, drop them in the comments below. I'll do my best to answer. And I will see you in the next one. Goodbye for now.